Hi there, I'm Hao, and this is just another video of me solving random linear problem. So today we have for sum. So given an array of nums, we have to find an array of all the unique quadruplets. So A, B, C, and D, right? Where A, B, C, and D have to be are the valid index from 0 to n minus 1, right? And then A, B, C, and D have to be distinct. So this is very similar to our three-sum problem here. So earlier, we solved our threesome problem, right? So our strategy was instead of finding a combination using a brute force approach, we would have a O of n to the third power, right? And instead, we sort our array first, right? And starting from I, and we can use the left and the right pointer um, to find the target sum, right? So using that's why we can reduce our runtime to n log n plus n square, which cancel out to of n square, which is much better, right? And we also have these two while loop here, right? Which means we can skip um the we can keep incrementing the left pointer or decrementing the right pointer whenever we found a duplicate, right? Which means we don't have to process it. We can improve the runtime on the average case, right? And same for the I. If I is equal to I plus one, then which means we want to skip it, right? We don't want to process it again, right? Let's say 1, 1, 2, and 3, right? So let's do negative 1, um, negative 1, 0. Oh, we have also have negative 4 here, right? From the example, this example, um, 0, 1, and 2. Right? So if I is here, right? And so the target is 0. So if I is here, which means the sum rate is will be negative 1, right? So in order to make up a sum of 0, right? All of the numbers that we need to use in our triplet, right, will be greater than or equal to negative 1, right? And we already find our combination from here, right, using the two pointer. So if we see another one again, which means we can safely skip it, right, to save some processing time. Okay. So the foursome was pretty similar. Instead of using the brute force approach, which is n to the fourth power, we can shorten the array first and reduce the runtime to n cube. Right? So we're gonna have something like this. Uh, so negative 2, 0, negative 2, minus 1, 0, 0, 1, and 2. Right, we're gonna have I and J. Right, I will always be one spot after J. And we have our left pointer after J, and the right pointer is always at the end. Right, um, our current sum will be negative 1. Right, so negative 1. Our target will be 0. Target is 0. Right? So negative 1 is less than 0, so we try to move to the right, right? So if we see the same element, we just skip it. Now we have the target of 0, right? So we add these four numbers into our resulting array, right? And then, yeah, when we found the target sum, we want to increment the left and decrement the right at the same time, right? Because if we only increment the, because if we only decrement the right, right? That is the three numbers in our quadruplet, right? So the only number that make up to the target sum of 0, the only number that is possible is the 1, right? Is sorry, -2, -1, and 1. Yeah, so this is our three numbers. So the only number that make up to the target sum of 0 is 2, right? So if we ever found a 2 again, it would be duplicates, right? And we are not allowed in duplicate in our result, right? It has to be a unique quadruplet, right? So we need to increment the left and the right at the same time. And whenever they overlap, we can just keep going, right? We can keep incrementing the j to here, keep going, right? And so on and so forth. Okay, so let's code this up. So we need to sort the array first. Okay, and then we need to iterate through the nums array minus 3, right? Because we need to save the space for j, left and right. Then for the j will start from I plus 1, and we need to set the two space, right, for the left and the right. So we minus 2 here, right? And then we can set up our left and the right pointer. The left equal to j plus 1, right, left, right equal to num minus 1, and y, left is less than right. We can calculate the sum, right, equal to nums of I plus num of j plus nums of left and plus nums of right, right? If the sum is less than the target, we want to increment the left, right? Else, if the sum is greater than the target, we want to increment the right, decrement the right, right? Else, which means the sum is equal to the target, then we can add it to our result. All right. So let me create that. Const result into an empty array. We can push this into our resulting array of four numbers, and we can return the result array at the end. And after that, we want to increment the left and decrement the right at the same time. Remember, right? And we can further optimize it by so if nums of left, right, is equal to nums of left plus 1, right, then we can keep incrementing the left. Then for the right, this is minus, right? So if we see the same number again, right, we don't want to process it. So y, nums of I is equal to nums of I plus 1. We want to increment I, and we do the same for j. Okay, and that's pretty much it. Okay. Why do we always have 0 here? Let's see. So, okay, we start from we sort the array. We iterating to the nums array. We have left, starting from j plus 1, and then right will be the last element, right? And y, left is less than right. We calculate our current sum. If sum is less than the target, we increment to left, right, to find a larger sum. If it's larger, you increment the right to find a smaller sum. If it is equal, then we're gonna push the sum into our current array, right? Which should be a comma here, right? Not a plus. So I think that is the bug. And it worked. Thank you for watching.